Hello. Hello.
Yeah. Okay. So, yeah, like I said, professors, PhDs, postdocs, temporary staff, technicians, and a hell of a lot of bachelor's and master students, and a yearly budget of about 5 million. This is one of the main labs, two of the main labs, and some of all these. Definitely not all of them. I stole these couple slides next from Stefano. They show some of the stuff that we do. So we have many different research fields that we work in, owing to the different professors that we have that come from different areas. Some of our main application fields are medical stuff and inspection stuff. So we get things like pipe robots, drones, all these kinds of things, as well as ultrasonic positioning devices, MRI safe, needle injection stuff. The robot is a really cool example, more of an inspection one. Um, and the research is very varied, from domain independent theoretical stuff such as energy aware port Hamiltonian based robotics, um, and actuation, which is more practical but very domain independent, of course, all the way down to things like this, like the needle insertion robot that I mentioned, which is completely MRI safe. Um, so back to my own slides. So these are some of the platforms that we have in TERRINet. So they come from 6 different labs at the university. Actually, this is not at the university. This is a facility that is outside of the campus because, as you can see, is massive. And so, yeah, starting from the top left, this is the ones that we offer from robotics and mechatronics. It's just manipulators. I'll go into details of each one later on, but then we have TechMed, which has just been reopened last Friday. Actually, we have a new TechMed center with a huge number of facilities. Um, SmartXP primarily provides some fast prototyping, makerspace, electronics labs, these kind of stuff, facilities, as well as an indoor flying cage with OptiTrack facility. Um, Space 53 is primarily aimed at larger scale flying experiments, primarily outdoors as well. And they have all the legal regulations and stuff in place if you want to have, let's say, larger scale drones, which you can't otherwise easily test. Then Lopez is the biomechanics department. That's a gate assistant robot, and the human media interaction lab. Again, very broad. There's a VR lab and a design lab, which is again this sort of collaborative makerspace type facility. So technical detail time. So this one, many of you will probably know. Just a 7 DOF manipulator. Um, yeah, weight, workspace range doesn't really matter here right now. But the way we have it set up is it's inside a cage with all the other manipulators, dedicated PC available, and then you program this using the standard KUKA APIs, which I think are C++, but also Java, if I'm not mistaken. We don't have a simulation environment present, but we can. I mean, we can work together and provide such a thing, of course. Um, I think more interesting are these actually. These are more, in my opinion, more modern Franca Emica Panda robots, of which we have 2, which we can use together. So that's pretty nice. They are significantly cheaper. You can tell by the, the low capacity. So they can be programmed by using by hand motions and the control panel, but also through Python, for example, C++. And there's again dedicated PC with a local LAN and a switch for programming these things. So you don't have to bring your own equipment for that. Yeah, what else? Yeah, these should be fairly obvious, right? Um, so like I said, there's a Ubuntu Linux machine that is used for that. Standard, what is it, 1604 probably? Maybe 1804, I'm not actually quite sure. And the local network, they are set up with ROS. So quite easy to read and send commands, torque, position, velocity, etc. Interface with C++, Python, and these things, I don't know if you're aware, they come with this sort of web interface as well. You can just browse to the device in a browser, and you get this really nice interface where you can program like complicated tasks and stuff like this, and you can do stuff by demonstration. It's quite cool. Again, there is not a simulation environment that we have installed, but it is available online. You can get it and you can just run it. If somebody does apply, one of you perhaps, then we can make arrangement as necessary. Um, programming knowledge is required, but this is much easier to program than the Kukas I've been told. I mean, I haven't actually worked with these myself. So technical support is provided by technicians, actually plural, and myself, because this is the lab that I'm in. And I mean, some scientific knowledge is assumed in applicants. We're not going to give full kinematics courses, of course. So some examples, yeah, teleoperation, human-robot collaboration, some learning, medical manipulation. So that's one of the examples that we're doing, applications that we're doing, like ultrasound positioning, eye and hand visual servoing, inspection and maintenance, medical stuff, yada, yada, yada. So there's many different things. So next, infrastructure, not just platform. So this is the SmartXP lab. That's one of the other labs at the university. They have two things, like I said, one rapid prototyping facility with Makerspace Electronics Lab, laser cutting, 3D printing, as well as some other stuff like VR glasses and sensors for all kinds of experiments. This is, again, this one of these open collaborative things, vague. So these are some of the printers and laser cutters that are available. I think a few more than those actually, but those are the main ones. There's also, by the way, it's not listed here, but there's also lots of printers available at RAM, although we haven't explicitly listed them in TERRINet. But and again, for these, technician assistance is available, obviously. So the main thing for SmartXP is the indoor testing of robots and particularly drones. They have this big flying cage. You can't really see very well here, but this is a really big space, and you see this sort of edge of this square. This comes down, and then this is a 5.5 by 7.4 meters flying area with OptiTrack, transparent protective walls, some nets, and some impact mats and foam, so you don't have to break your drone all the time. So there's 10 OptiTrack cameras, and I think there's now 4 or 6 more, which will be placed close to the bottom, because you have, obviously, if they're all up there, you have issues with tracking drones really low. So that's the plan to improve in the few months coming. There's a dedicated PC with a remote desktop. There's a Windows 7 PC, I think, and I'm not exactly sure, but I think the measurements are made available through ROS in this particular case, so you can close the loop with the drones through the ROS connection to the PC, because the PC itself is headless. There's no display on that. And there's a drone with this one that we actually make available through RAM, through the Robotics and Mechatronics Lab, with a Pixhawk 2 running peaks for flight computer and a NUC on board, which is kind of cool. Yeah, skill requirements. You need some drone experience, of course. I don't think there's a pilot available right there, and you need some experience with flight computers, because we can't teach that entire thing from the ground up as on the usual visit, I would say. Again, technician assistance is available here, same technician as the other one for SmartXP, and we have some PhD students that have been flying the drones for a long time, including using the OptiTrack, so they can help if they're available at the time, if that's necessary. So, only 10 more slides. Don't fall asleep. So HMI, Human Media Interaction Lab. So they again have virtual reality and tracking facilities, so very similar to SmartXP. I'm not exactly sure what the tracking facility offers. They have a lot of human media interaction platforms, some of these, and also some home developed platforms. One you can see here is the Frog, these social type robotics. And they have all these other human interaction software stuff that they have already pre-built and you can use for your experiments. And yeah, there's some example applications here, like I alluded to just before: social robotics, entertainment computing, and they also have a bunch of other interactive devices where you can interact with computers in different ways. So this is really a big part of their focus. Now, HMI also offers the design lab, which is a massive area. It's mostly aimed at connecting researchers together and actually, like I described, like I wrote here, it's a bit vague to me how this is offered within the TERRInet project. So I found this out mostly while making these slides. So this is kind of what I stole from their website, to be honest. So it's mostly, you know, meeting rooms, lounges, maker spaces, some testing facilities, photography place, so you can make some nice pictures of your prototypes and all this kind of stuff. And they have this program called Design Lab Research Fellows, where they connect students. So that's one of the primary groups that we're addressing with TERRInet, right? Connect students to more established researchers to create new research collaborations. So this is nice, but to me it's a bit vague. So I'm trying to find out still what exactly they want to offer within the TERRInet project. And one other function that they have is they act as a broker between society and academic expertise present at the university. So they also work with a lot of public-private collaborations. So Space 53 is the massive flying facility that I was talking about before. So they have this 3 kilometer runway for testing fixed wing UAVs. Extremely cool. I haven't actually been yet, but I want to. And they have all the proper legal and procedural stuff around it for testing, you know, proper size big UAVs, even certified pilots. So that this is really something that you need if you want to try flying bigger UAVs. There's a no-fly zone around the facility, so this is proper stuff. And yeah, they also allow testing of other vehicles, but the primary goal is flying vehicles. And they also have a number of simulated areas, so industrial and urban environments, basically fake buildings and stuff like that, where you can test your applications. This doesn't work. So they also have an indoor testing area. Nice if it rains, which, you know, you're in the Netherlands. There's just no motion capture in this environment, so it's different from Smart XP. They also have offices and technical workspaces, like pretty much all of them. Again, example, you know, testing UAVs, other unmanned vehicles in different environments. In terms of training, they do a lot of procedural and legal assistance for UAV testing and certification, drone pilot training, so you can officially be a pilot, and they actually have a whole bunch more. They're quite flexible, so if you have questions, let me know, and we'll bring you into contact with them. So the TechMed Center is hopefully the last one. That was reopened actually last Friday. This is a very big center, so this is the building that was finished less than half a year ago, I would say. It's quite nice, and they have a very big number of facilities, all in the medical range. Simulation and training, biorobotics, imaging, physiology, bioengineering, and health and well-being labs. And I actually have a little video that has come out just Friday, which I can show now. It's a bit long. It's like 2 minutes, but it's the best overview I can give of TechMed. So I don't think I have audio, do I? Philip, do I have audio? I don't think I do. Philip, do I have audio here? Do I have audio, like sound? That would be very helpful for this video, actually.
So it should work with HDMI.
Oh, so okay, let me just try to unmute and then see if something works. I think it's coming from my. Okay, maybe I can. Ah, wait, there we go. Yeah. HDMI. No.
It's not working. Okay, so that should be.
The volume's up.
We can try with that.
My volume's up. Oh, yeah. I think you increase the volume of the microphone actually instead of the volume of the.
Oh, yeah. Sorry.
No, I should. Okay. I should change back to speakers. Oh, it's already okay. No.
It should be working. Well, we can
Oh.
just use the mic and.
Yeah, you know what? I'll use my speakers and then I'll hold the microphone next to it. How about that?
Can technology help healthcare professionals to make a diagnosis? Could biorobotics contribute to more accurate interventions? And could they be the solution for a better life? Is it possible to merge humans and robots? At the University of Twente's Technical Medical Center, we focus on these and other questions every day. Biorobotics is one of the domains of the Technical Medical Center. Here, we combine excellent research and education in an environment equipped with state-of-the-art facilities. We improve healthcare through the development of personalized technology. In the biorobotics domain, we develop solutions using robot technology. Our goal is to improve the diagnosis, evaluation, and treatment of patients suffering from conditions such as cancer and cardiovascular disease. In addition, this domain focuses on improving the quality of life of people with a physical impairment and those who need a prosthesis. The challenges in this domain range from MRI-guided chest biopsy procedures with a robotic needle manipulator, rehabilitation robots, and wearable robotics, to CT and ultrasound-guided robotics and needle steering. We provide pioneering and agenda-setting education that equips students with the skills to implement this knowledge in the healthcare sector. We collaborate closely and successfully with academic hospitals, businesses, governments, and other knowledgeable institutes. The MURAB project is a great example. In this project, we're working on more accurate and effective biopsies for cancer diagnostics with the help of a robotic arm. One thing is certain, human-oriented robotics will revolutionize our society.
As you see, we used our best actor for that. Right, so yeah, this was the... Is it still working? It's just a bit, okay. So this is the one for the biorobotics part. There's videos for each one of them, but I won't bore you with those. So this is a very, very big facility. They have a huge number of things. This is a bit of a list of the stuff that they were offering before the new center opened, and I have to update it for the new center. I'm not sure what exactly they will offer within TERRINet, but this is some of the examples. So simulated operating theater, an intensive care unit, various medical skill trainers, those apparently, and even full body patient simulators and stuff like that, and a whole bunch of MRIs and other imaging modalities, which are probably still offered, but I would have to check. So my intention is to take all of these and revise them and then put them also on the website. So each of the for the TERRINet people, each of the platforms that we have on the website are more clearly described, because for many of them you can't see what exactly the software is. So everything that we present today, I think it should actually find its way to the website. But so yeah, again, a little list that I stole from the old documents. There's a whole bunch of potential applications here, depending on what they offer in the new center. But performance assessment of interventions using robotic systems, interfacing different solutions with state-of-the-art medical devices, which are, certifying medical devices is a very problematic thing. So using existing devices is a high priority in many cases. Yeah, testing imaging modalities and a whole bunch of collaborative work with medical professionals. So skill requirements and training, I found that very hard to define in this case. I'll leave that as a question mark for now. Now we make our way to the final, the final platform. So this is Lopez. This is a gate assistant robot that that was developed at the Department of Biomechanical Engineering. We've had this one for a while. This, I think, is the second generation. So this is a very easy to use robot with 8 power degrees of freedom, and full sensors, full admittance control. So very nice. It's used quite often for exoskeleton design and stuff like this. Well, yeah, that's in a possible application as well. Human-robot interaction, skeleton design, gait assessment, gait training, and some human-in-the-loop testing. So they do a lot of stuff with this. And this one, I have a bit more information about the technical aspect of it. So the way this is controlled is actually using MATLAB Simulink real-time. If you're aware, this is basically you use your Simulink models and you compile them to C code underwater. Of course, you don't really touch them, and they run on some dedicated device in real time. So this makes it really easy to really quickly prototype your controllers and run them on the hardware. And they provide actually a Simulink block library, so I don't even have to think about how to interface with hardware. You just have blocks to get measurements and send torque commands or position command or velocity commands. And they already have a full admittance control system set up, so this is nice. So skill requirements, obviously MATLAB Simulink, and of course some idea of human gait and high-level gait control would be nice. They have pretty decent training. I mean, obviously some training is required to even use the device, but they also have some assistance from their scientific staff to provide you with gait control assistance. Development assistance, sorry. And they wanted me to tell you that it's not available from June to August. There's a few key papers that you could look at if you want to know more about this device right here. And that's pretty much all for me. I hope I was quite fast. Yes, I was. So thank you.